So for today's experiment, we are going to look at a situation in which baby Jane is frequently ill and shows signs of being cold. The doctor advised that she should always be kept warm. Neighbors gave baby Jane's parents 3 clothing materials to keep baby Jane warm: wool, cotton, and polyester. Now the parents had difficulty deciding which material would be best to make blankets to keep baby Jane warm and stop her from getting ill frequently. So we need to devise a way in which these parents can determine which material is the best material to keep this baby warm, right? So of the 3 materials provided, we are going to devise an experiment to test those 3 materials. Now, when we consider what the situation is, we are looking at trapping heat, right? Or we are looking at what type of materials provide for excellent insulation between polyester, cotton, and wool, right? So we need to devise a way in which we could determine which of those 3 materials will be best, right? Now, if we are going to plan an experiment, we need to do things in a manner in which the odds are equal for all 3 types of materials that we are going to investigate, right? So, which means if we want to compare the 3 materials, we need to consider something called control variables, right? Now, we would have discussed what controlled variables are in experiments before. But just as a reminder, a control variable is something that remains constant throughout your experiment, something that doesn't change, right? Now, if we want to compare materials in terms of what is best for trapping heat, we need to keep some things controlled or constant between those 3 materials, right? For one thing, we would have looked at how temperature affects the ability of a material to trap heat. So which means if we are going to conduct this experiment, we need to have 3 materials of the same color. So we can't give the parents a black cotton blanket versus a white wool blanket versus a green polyester blanket, right? Different colors of materials will trap and release heat differently. So we need to decide on what type of material we are going to use, or what color of materials we are going to use between the 3. So for this experiment, we will use white, right? So white cotton, as we could see here, right? It's white cotton, white polyester, and white wool, right? So we need to keep that constant. Another thing we need to keep constant is we have to consider as well, if we want to determine what is the best material to trap heat, right, to keep a baby warm, we need to consider how are we going to do that with these 3 materials. Now, we want to simulate a real-life situation, wrapping a baby in a blanket. But we can't exactly experiment on children now. That would not be something good, right? So we need to find a way in which we could carry out this experiment without actually putting someone's life at risk, right? So we need to try to find a material or something that we could use to determine how well it will keep heat. So what we've decided to use are a couple of tin cans, all right? Now, we're going to go back to what we mentioned as controlled variables. Now, the whole point is the tin can here is supposed to represent the baby. The material is supposed to represent the blanket. Now, if you notice, all the tin cans are of the same size. And they aren't just of the same size. The tin cans chosen would have been tin cans manufactured at the same time, right? Same manufacturing date, all of them containing the same material, right? And all of them would have been of the same size. So if you want to compare heat losses, we can't have a tin can that is 16 ounces and another that's 8 ounces. Different materials, different sizes will trap and release heat differently. So we need to keep the sizes of the tin cans consistent. So let's do a little backtracking a bit, right? So we want to keep the baby warm. So we're going to represent the baby by one of these tin cans, right? Now, in order to carry this out effectively, we need to wrap each tin can in the same color of material, right? And determine how best each material traps heat or keeps heat, sorry. So we're gonna wrap them with one with cotton, one with wool, and one with polyester. Now, you'd have noticed that I mentioned 3 materials, but I have 4 tin cans. Now, the 4th tin can is sort of like a comparison, right? A can that we use to compare all the others to. That can will be a can that is uninsulated, right? That isn't wrapped in any blanket. A baby that is not covered with a blanket. What will happen? So one of these cans, we are going to measure how heat is lost from it and have it unwrapped with any material, right? And once we have that and we collect data for that, we could actually compare all the other materials to that one to see how well they trapped heat, right? So how are we going to carry this out? So we've discussed again the material, the cans to represent the baby, all of them are the same size because it's only that baby we are looking at. So all cans must be of the same size, volume, weight, made up of the same material, manufactured on the same date, because if they were manufactured in different times, there's a chance that the manufacturing process may have changed, the material might be thicker and so on. So that's why we are choosing cans that were manufactured at the same time. We are also choosing cans that would have contained the same materials, right? So we're trying to keep everything as constant as possible, right? Those are our constant variables. We want to eliminate errors, right? Now, choosing material that's the same color is only one step in the material. We need to consider what we do when we wrap a baby in a blanket. And that's what we do, we wrap a baby. So we need to take our tin can and wrap that tin can in our material, right? So we're gonna do this, right? We're gonna wrap our tin can as if we were wrapping up a baby in a blanket, right? So just like this. But we need to take that a little more, make that a little more precise, right? We need to measure exactly how much material we are going to use to wrap this baby with, right? We can't just wrap the material randomly around and then measure how heat is lost from it. We need to have a fixed size of material, right? So for example, I am looking at how much material will wrap around this baby twice, right? Because I want to keep the baby warm. Simply covering her with one layer of material isn't sufficient. So I want to see how much material I need to wrap around this baby twice, right? So that leaves us with here. So I need to measure out how much material I need to cut to make a blanket for our baby, right? So not only the length of the material, but also the height of the material. Now, I would have measured this tin can previously, and you would see that the tin can is roughly 10 centimeters long. All right? So if you look at that, that's 10 centimeters long. So I am going to cut this material 10 centimeters long as well. Alright, so we're going to measure and cut 10 centimeters long, and we're going to cut for how much material for the length that would have wrapped around the can, which ended up being around 45 centimeters. So, sorry. So basically, we are going to cut a 10 centimeter long piece of material by 45 centimeters long, and we are going to repeat that for our polyester as well as our wool, right? Now, there's only one problem with the wool. As you can see, our woolen blanket is not white, but we do have a sort of whitish trimming. So that's what we are going to use. So now this will actually introduce errors into this, right? So we'll stop there and continue in a moment. Right, so we're cutting this cloth length to 45 centimeters because that's how it wrapped around twice. So 45 by 10. We are going to repeat that cut with our polyester and our wool. Now, you'll notice a little something odd about my wool material, and it contradicts a bit with something I would have mentioned earlier, right? We want all the material to be of the same color. This is white, the polyester is white, the cotton is white. But as we could see, our woolen blanket isn't white. It was sort of hard to source a pure white woolen blanket. Now, if you notice, the ends of the blanket are white, however. So what we will do, thankfully we only need 10 centimeters long of it, we'll cut on the edge, and that should help. But it's still a little colored, so that would introduce a little bit of errors and a little bit of a limitation to our experiment. Now, we would have to consider that when we are explaining this, right? So let's get started now, right? Now, you'll probably be wondering, okay, so we have a can, we have our material, clearly we have a thermometer here. How are we going to measure how much heat each material can trap? Well, that's a little simple, actually. What I plan to do is, I plan to boil some water, right? And I'm going to measure about 200 cm cube of that boiled water into each tin can. I'm going to do it one at a time, which might introduce errors or might not. We'll see. And as soon as I pour that into the can, now remember, I'm going to do a can that's unwrapped to represent a baby that has no blanket on, how heat is lost from that baby, right? So I'm going to have one can uninsulated and the other three insulated with cotton, polyester, and wool respectively. I'm going to pour in a measured amount of water that was initially boiling, and I'm going to start taking temperature readings in each of them every 2 minutes. I'm going to take an initial temperature first as soon as I've poured the water in at time 0, and every 2 minutes for 30 minutes I am going to record how the temperature drops, right? And I will plot a graph of that. So let's get that part going now. First, let's cut our material so that we could wrap each can and begin before we start measuring temperature. So notice 45 cm, and we have a little notch there, and then we need to measure from that notch 10 centimeters, so that's here, right? So I'm gonna just bore a hole so I know where I'm stopping. So I'll go a little more than 10, I'll go 11, just to be certain. And I will do that with each material, right? We're going to cut up until there. And we're going to repeat this for all pieces of material. Again, for the polyester, markings are made 45 centimeters by 10 centimeters, and this will be cut now. Forgive the little stain on it. Don't worry, that's just food. That's not blood at all. So the material is going to be fastened around Baby Jane using paper clips, right? So just like this, simple paper clip to fasten here and at the bottom there. Right, now this would have been done for all materials. That would have been the fastener used on the cotton one as well. Wool material cut to specifications, just to be wrapped around can now. Right, so we have our baby wrapped in 3 different materials, and our baby not wrapped in a blanket. So polyester on the left, cotton in the middle, wool as the third one, and of course unblanketed baby on the end. So we're going to look at how each one of those materials helps to keep the baby warm. So what I'm going to do, I'm going to boil some water, right? So boiling meaning it goes straight up to 100 degrees Celsius. And I'm going to pour that boiling water into each can. Now I'll do it 1 can at a time so that there is no problem with me trying to shift and trying to measure and getting not getting the values I need. So what I'm going to do, as soon as I pour, I'm going to start with the... So what I'm going to do is I'm going to start with the baby that has no blanket. I'm going to pour in 200 cm cube of boiling water into here. Record the highest temperature reached, that'll be time 0, and as soon as I get the highest temperature starts falling. Now that's going to happen instantly because the water will no longer be in a environment where it could maintain 100 degrees Celsius. So as soon as that happens, every 2 minutes I am going to take temperature readings for 30 minutes, right? So let's get that going.